Hello, this is part 2 of section 5.1 on nth roots and rational exponents. Go ahead and take a moment, pause the video to recall what we did in part 1 of our lesson on 5.1 by practicing questions 1, 2, 3 on the screen here. In example 1, what we're looking for is the number x that we raised to the power of 3 to get the number negative 125. Now to solve that, we can cube root both sides because cube rooting and cubing are inverse operations. And then on the right, I cube root the negative 125. So my number that I'm looking for is equal to the cube root of negative 125. Since we're looking for an odd root, this is the third root of negative 125, I do not need to worry about a positive and a negative option. We're only looking for the three numbers that multiply to give us negative 125, and those numbers are negative 5 times negative 5 times negative 5, because this multiplies to give us positive 25 times negative 5, which is negative 125. So when we factor our negative 125, we get negative 5 times negative 5 times negative 5. There are three identical numbers. Because there are three of the same number, we get to take them out of the radical to get just negative 5. Now there's nothing left. Once I take out the negative 5s, there's nothing left. So the number that I'm looking for is just negative 5. And the reason that this is true is because negative 5 raised to the power of 3 is negative 125. We can think of that as checking your answer. So our third root is negative 5. In number 2, we're looking for the number that we raised to the second power, the root here is 2, to get negative 400. In order to undo the square, I square root both sides. So x would equal the square root of negative 400. Now this is a problem because there's a negative under an even index, which means I could take out that negative as an I and then have the square root of 400. However, we are looking for the real roots of negative 400. This is not a real root. So we say exactly that, not a real root. Last, we're looking for the number that we raised to the power of 6 to get the number 64. I go ahead and sixth root both sides of my equation. Since we're doing an even root, I do have positive or negative. When I factor my 64, we can multiply 16 times 4. 16 is 4 times 4, which is 2 times 2 times 2 times 2, and my 4 factors into 2 times 2. So when I break down my 64, I see 1, 2, 3, 4, 5, 6 2s. And that's exactly what we're looking for. 6 of the same number that multiply to give us 64. So the sixth root of 64 is just 2. We do have positive or negative in front, so our roots here are positive and negative 2. And to think about checking it, what we're looking for is the number that we raised to the power of 6 to get 64. So our claim is that 2 would work. And also we are saying that negative 2 would work. Sure enough, if we punch both of those into our calculator, we will get 64. On our next slide, we have 6 equations that are all set up for us. Instead of writing the equations, we've already started with the equations, so we'll go ahead and jump forward to just fourth rooting both sides to undo our exponent. Since we are taking an even root, we do need plus or minus the fourth root of 256. When we go to factor this, 256 is 16 times 16. 16 breaks down into 4 times 4, and another 4 times 4. And we are looking for a group of 4 identical factors. Well, I could keep factoring, but I'm not going to because I found 4 identical factors. 4 times 4 times 4 times 4 gives me that 256. So x is going to equal positive or negative 4. To do a quick little check, we are saying that x to the 4th power is 256. We are claiming that positive 4 works, And we are also claiming that -4 works. Sure enough, when you punch both of these into your calculator, you will get 256. In number 19, we do need to divide by 3 first because our exponent is not attached to the 3 that's the coefficient. So x to the power of 3 is equal to 125. From here, I cube root both sides. So x is equal to, and we're looking for the number that raised to the power of 3 gives me 125. 125 is 5 times 5 times 5. That's 3 identical factors, and that's exactly what we're looking for. So the number that we want is 5. And again, to do a quick little check, we can say the number raised to the 3rd power to give us 125 would be the number 5. In number 20, we cannot get to the -6 because it's stuck in parentheses with the exponent. So in this case, I do take the square root first. Don't forget your plus minus. The exponent and the radical cancel, so I'm left with x minus 6 is equal to positive or negative square root of 40. When I go to factor my 40, I have 4 times 10. My 4 breaks down into 2 times 2, and my 10 breaks down into 2 times 5. I am looking for 2 identical numbers, and in this case, I do see 2 identical factors, but there are others that do not pair up. So these 2's that I've highlighted get to come out of the radical, but then these that did not pair up with anything have to stay underneath. So I have positive or negative. A 2 gets to come out, and then underneath I have the square root of 10. To take a number out, we do not multiply. To leave a number in, we multiply the 2 and the 5 together. From here, we go ahead and we add our 6 over, and I prefer to put it in front. So x is equal to positive 6 plus or minus 2 square root of 10. All right, go ahead and pause the video and try 21, 22, and 23 on your own. In number 21, I just have the number 3. In number 22, we had the 5th root of -112. The only thing I could do is take out a -1 in this situation because the 112 did not break down into 5 identical factors. And in number 23, I have the 4th root of 6 that is either positive or negative. Pause the video if you need to review the work done for any of these. To evaluate expressions with rational exponents, these are just radicals in disguise. What we really have here is 16 to the power of 3. That numerator means it's the exponent on 3. The denominator tells you that there is a radical over that 16 to the power of 3. The denominator of that fraction is the index of your radical. We can put the exponent inside, or we can take that exponent of 3 and put it outside. So I have this 2nd root of 16, and then I cube root it. I would much rather approach it this way because I know what the square root of 16 is. That's the number 4. And then if I raise that to the 3rd power, I get the number 64. So the denominator means that's the root that we are taking, and the numerator means that's the power that we raise it to afterwards. In B, I do see a negative exponent. All that means is that we're going to drop that 32 to the denominator, and then my exponent becomes positive. On top, I fill in my fraction with a 1. This is 32 to the power of 3, but then I see a fraction. This 5 tells me that I have a radical with an index of 5, or the 5th root of 32. Let me fix that. This should be 32 to the power of 3. So again, I would much rather think of this as the 5th root of 32, and then when we're done, we'll raise it to the 3rd power, because I know what the 5th root of 32 is. The 5th root of 32 is just 2, and then I want to raise that to the power of 3. 2 to the power of 3 is 8, so all of this simplifies to 1 over 8. Go ahead and take a minute, pause the video, and try 5 through 8 on your own. So for each of these, the denominator of our fraction became the index. Here, the denominator of my fraction became the index. The 4 is the denominator, it became my index, and the 8 is the denominator, it became my index. I kept the numerator with the 4 or with the base. I just pulled it to the outside of the radical. So here my numerator is a 1, here my numerator is a 3, and here my numerator is a 7. Pause the video if you need more time to check your answers here. Take a moment, pause this screen, and try these 6 one more time. You can go ahead and check your answers. Again, pause and spend as much time on the screen as you need. Lastly, we're going to talk about evaluating with a calculator. So this is going to be approximations because these do not simplify to integers. They are going to simplify to irrational numbers. So on our calculators, we can go ahead and type in a rational exponent. Your calculator might look a little bit different than mine, but I'll go ahead and try and show you a few different ways. Because it can be kind of difficult to input a fraction into a calculator, you have the option of turning your fraction into a decimal. So if I want to type a decimal in instead, I could put 0.2 instead of the 1 over 5. So this would be 9 to the power of 0.2. Then when I go to type that in, I put my base first. Here is my x to the power of y button. Or I see this little kind of caret pop up. A lot of calculators will have that button as an actual button on your calculator in place of the x to the y. But I hit 9 as my base, and then I raise it to the power of 0.2. And I get 1.55. It says round to 2 decimal places, so this is approximately 1.55. Here I have 12 to the power of 3 over 8. If you want, you can go ahead and type in the 3 divided by 8 into your calculator to get a decimal. I get 0.375. And then I type that in, so 12. I hit my to the power of button, and I get 0.375, which approximates to 2.54. I'll bump that 3 up to a 4. So approximately 2.54. If you don't have the x to the power of y button, you might see on your calculator the little caret button or the up arrow. So you can hit 9 and then hit the button that's an up arrow and then type the exponent that you're putting in, which in my scenario is 0.2. Here I would have 12 and then I hit the button that looks like an arrow, we call it a caret, and then I would type my exponent 0.375. For C, your calculator will not type in radicals. So what we can do instead is we can write this as an exponent. I know that a radical actually means it's the denominator of a fraction. So my exponent, 7 to the third, is going to be divided by 4 because 4 is the index of my radical. So this written as an exponent is 7 to the power of 3/4. If you want to type it in as a decimal, you can, 0.75. So 7 to the power of 3/4 or 7 to the power of 0.75. 7, I hit my button x to the y, which means to the power of 0.75, gives us about 4.30. So approximately 4.30. Okay, go ahead and take a moment and use your calculator to approximate numbers 9 through 12. I will walk you through these one more time. 6 to the power of 2 over 5. So I do have an option to put parentheses here. And if you are typing in an exponent that's a fraction, you do need parentheses. If you don't have the parentheses, then your calculator will not know that all of that fraction is meant to be in the exponent. So these parentheses tell the calculator that the entire fraction is the exponent. 0.4 is the fraction, and then when I hit equals, it'll compute it all together. So approximately 2.05. Number 10, I've got 64, and I'm raising it to the power of, I put my parentheses, and then I type my 2/3, but I do want it to be negative. So 2, make it negative, and then divide by 3. Calculators may process negatives differently, so be careful with how you're putting it in. I get 0.0625. So this is going to be approximately, if I'm rounding to the second decimal place, 0.06. So approximately 0.06. Number 11, this is going to be 16 to the power of 5, but then that radical means the 5 is divided by 4 in the exponent. So 16 to the power of, in parentheses, 5 divided by 4. Close the parentheses, and I get 32. So this is approximately, or exactly in this case, 32. Lastly, I've got negative 30 in parentheses, because if it's not in parentheses, then we actually do not include the negative. But the negative is a part of our radical, so I do put it in parentheses. Negative 30 squared. And then my index is 3, so I divide my exponent by 3. On my calculator, I have in parentheses 30, but it needs to be negative. And then I'm raising that to the power of, in parentheses again, 2/3. Close my parentheses, and I hit equals. And I should get approximately 9.65, so about 9.65. All right, last slide is for you to practice. Go ahead and pause the video and practice these 6 on your calculator. All right, you can go ahead and take a minute and check all of your answers here. If you've made any mistakes, please go back, find them, and correct them. Thanks so much for watching. Have a great rest of your day.